Now that we have designed a model to capture data about our horses that we're going to be taking care of, in Module 10.1, we are going to look at implementing this model in a single table in our database. In the following examples, I am going to be using a SQL client called dbeaver. It's free and fairly user-friendly, so I think it makes a lot of sense for this class. But there are, of course, many other SQL clients you could use or might have to use in your job, but they all work in more or less the same way. So there is more information about connecting to Oracle and configuring and using dbeaver on Canvas, but if you do have any connectivity issues, please just reach out and let me know. So throughout this lecture, I will be switching back and forth between the slides and our Oracle connection using dbeaver and executing some SQL code, but all of the SQL that I am executing is found in the slides that are posted to Canvas, and then also there is a text file that contains all of the SQL statements, so you can just copy and paste to follow along. As we get into the task of database creation, there are a number of components that kind of go together here. So first and foremost, we're going to be looking at the creation and modification of the actual database tables and the structure therein. Also, enforcement of our integrity constraints, so things like our domain constraints, our unique primary key constraint, our attribute types, and things like that. And then finally, populating the data into the table itself. Now, in order to really kind of see the fruits of our labor, while we are right now focusing on our data definition language, it'll be helpful to kind of understand some basic insert and select statements. So to insert data, we're going to start with the SQL keyword insert, then into, then the name of our table, then the word values, and then in parentheses, a comma delimited list of values. Or another way we can do this is to say insert into, then the name of the table, then in parentheses, a comma delimited list of attributes, then the word values, and then in parentheses, the comma delimited list of values that correspond to those attributes that we provided. So this is just two different ways of getting to the same ultimate outcome. This second way here is a little bit more flexible because we can kind of specify the order of the attributes and then the order of the values, and as long as that matches up, everything is fine. If we use this first format here where we only provide the list of values, there's two things that make this a little bit challenging. One, we have to provide the list of values in the same order that the attributes were defined when the table was initially created, and we may not readily have access to that information. And then also, if we use this first format, we are required to provide a value for every single attribute. So by using this second format here, it gives us just a little bit more flexibility if we don't want to provide values for certain attributes, or if we don't know the order that the attributes were originally defined in the table. This second way is a little bit easier to use, but throughout the examples we'll kind of use both of these formats, so I just wanted to point both of them out. So that's to write data into our table, and then to read the data back out of the table, we're going to use the command select. And so all of our read operations follow this basic format where we start with the SQL keyword select, and then whatever attributes we want to project out of the table. In this case, the asterisk represents all attributes, or we can provide a comma delimited list of attributes so we want to see the values for. Then the keyword from, and then the name of the table. So for example, if we had a table called customers and we just wanted to see the values of all the attributes about customers, we could say select asterisk from customers, and that would give us all rows and all values about our customers. Now, after the first exam, when we get into modules 11 and 12, we're going to have a lot more discussion about more powerful things that we can do with our select statement. But for right now, this is enough to kind of get us started. So a few things to note about structured query language. Capitalization and spacing do not matter. So we can write our SQL commands in all capital letters, all lowercase letters, a mix of case. It's all going to be processed just fine. And then we can have either just one space between each element of our SQL command. We could have, 5 or 6 spaces. We could have a tab. We could separate things across multiple lines. Oracle is not going to care. That all works just fine. Now, the one place that capitalization does matter is when we are searching for a particular value of a string. Oracle and most other databases are going to be case sensitive. So if you were looking for someone's last name, for example, and in the database, it's has kind of the typical format of the first letter of the last name being capitalized and the rest being in lowercase, you would need to make sure you match that case. But for your commands themselves, capitalization and spacing do not matter. As I mentioned, we can spread commands across multiple lines, or we can write things out on just one line. A well-formed SQL statement should always end with a semicolon. Now, if you're running just one command at a time, most EBMSs are not super picky about this, and they'll still execute that single statement just fine, even if you don't include the semicolon. However, if you are going to be executing multiple commands at once, it is required that you put that semicolon so the DBMS knows where one statement ends and the next begins. So I think it's just a good habit to get into for ending all of your SQL statements with a semicolon. As with really any kind of programming, very important that you match up your opening parentheses or quotation marks with a closing parenthesis or quotation mark. So you're going to get syntax errors if you have kind of a mismatch on your parentheses or quotation marks. When we're talking about text attributes or like string values, all of that is going to be enclosed in single quotes. And in the code examples that we're going to have coming up, anything that's optional is going to be enclosed in these square braces. All right, so for creating a table, the syntax for that command is to use the SQL keywords create and then table, and then the name of the table we want to create, and then in parentheses, a comma delimited list of table elements. Okay, so table name is just the name of the table. This might be like customers or employees, or in this example, horses. And then each table element is either the definition of a column or an attribute name, or the definition of a constraint. So the basic syntax for defining a column is to provide the name of the column and then the representation or the data type of that column, whether it's a string value or a numeric or something like that. And then optionally, if we want to have a default value for that attribute, we can provide that here. And then also optionally, if we have any constraints that we want to apply, like our domain constraints, or whether or not it has to be unique or it has to have a value at all, optionally, we can provide that here at the end. Now, one thing you might notice, I did say that our capitalization doesn't matter. But kind of the convention for giving code examples is that we will have our kind of SQL keywords, our reserved words written in all capital letters, and then things like our table names and attribute names we're going to have in mixed case. So to create a very basic version of our horses table that we just created our data model for, we would use a statement like this. We would say create table, and then the name of our table, in this case horses, and then open parenthesis, and then the names of all of our attributes, name, color, spot, sex, weight, and their data type. So name, we're going to say is of the data type variable character or varchar, and then a length of up to 50 characters. Okay, so a little bit later we'll talk more about data types and their meanings, so don't get too worked up about this just yet, but just know that varchar is kind of a very flexible general use text string data type. So name is going to be a string of up to 50 characters. Then we have a comma. Color will be a string of up to 50 characters, comma. Spots is going to be a string of just up to 3 characters because we know that the values for this are either yes or no. So we don't need more than the 3 characters to capture the word yes. Then a comma. Sex is going to be a variable character string up to 1 character because we know the values for that are just either M or F. And then weight is going to be a numeric data type, and in this case, we'll call it an integer. So let's go ahead and switch over to Oracle and execute this code. So I'm just going to copy and paste this code from the document that is posted to Canvas, also available in the PowerPoint slides here. Create table horses, and then in parentheses, all of our attributes and data types. I'm going to select this and click the little run button here, and you can see that it says we have successfully created our table. So if I right click on tables over here and go to refresh, you see that we have our horses table. And then if I were to say something like select asterisk from horses, this is going to show us that we have our attributes here, name, color, spot, sex, and weight, but there are no values yet, and that is to be expected since we haven't inserted any values yet. So let's go ahead and resolve that. All right, so here we see the code that we're going to be using to insert data about some of our horses. And again, this just follows the format that we saw a few slides ago. Insert into the name of the table, in this case, horses. And then in parentheses, this comma delimited list of attributes, name, color, spot, sex, weight, then the word values, and then in parentheses, a comma delimited list of the data values, Sam, Brown, no, F for female, and 1500 for the weight, right? So this just corresponds to the attributes that are in the list before the word values. And for our text strings, note that we are wrapped in these single quotes. So again, I'm just going to switch over to Oracle and copy and paste these insert statements from the documents posted to Canvas. So here we're inserting data about these horses. Since we have multiple SQL statements here we want to execute, we need to click this third button here, which is to execute a SQL script, as opposed to this first button up top, which just executes a single command. So since we have multiple insert statements here, we're going to click this third button. And when we do this, we see that we have inserted 8 rows into our table. So now if we say like select asterisk from horses, we see that we have 8 horses here: Sam, Erica, John, Trotty, Rio, Robin, Katie, and Pegasus. And they all have values for color, spot, sex, and weight. All right, so again, right now we're mostly focused on creating the tables, but I do want to take just a moment to give a high-level overview of our select statement and kind of some of the things that we might expect to do in the coming weeks here. So the general form of using our select statement is this select from where block. And this is going to be the foundation of all read operations that we do in SQL. Select, and then whatever attributes it is we're interested in seeing from whatever table or tables the data is being stored in, and then optionally where some condition evaluates to true. So this condition is going to be a Boolean expression that is evaluated for every row in your table, and if it evaluates to true, that row will be returned, and if it evaluates to false, that row would not be returned. Right? So a couple of things we could do, and what we just saw here, select asterisk from horses, that shows us all the horses. If we wanted to see only our female horses, we could say select asterisk from horses where sex equals F. So switching over to Oracle, if we typed in the SQL here, select asterisk from horses where sex equals F, we see just our 4 female horses, Sam, Erica, Rio, and Katie. If we want to see our male horses, just change this to where sex equals M. And we see our 4 male horses, John, Trotty, Robin, and Pegasus. So one important thing to note is this Boolean expression is case sensitive. So since we've stored these values of M and F as a capital M and F, it's important that that's what we are looking for in this condition. If we said where sex equals lowercase m, we see that we're not going to have any results returned at all. Now we could also have some other conditions, like if we wanted to see all of our brown horses, we could just say where color equals brown. Again, important that we have our capitalization matching up here. If we wanted to see our yellow horses, where color equals yellow, and we see Erica and Robin here. And then again, if we wanted to see all of our horses, just select asterisk from horses. If we want to see all of our horses that weigh over 1,500 pounds, select asterisk from horses where weight greater than 1,500. So we see our three kind of larger horses here. And of course, we could also have some more complex queries where weight is greater than 1,500 pounds and color equals brown. And we're just going to find our large brown horses. However, I'll point out now that we do have some problems in our database, right? Based on our previous discussion, we have some data integrity constraints that should have been applied to the database. So, for example, we said that horses are uniquely identified by their names, right? Now, I don't know if this is the best long-term decision for a unique identifier, but at least based on what we've discussed so far, we said names should be a unique identifier. We also said that we're going to have a domain of reasonable values for color, right? In this case, maybe black, white, brown, gray, yellow, and red, something like that. We said weight should be between 800 and 2,200 pounds. Sex should be either M or F, and it is required to have a value for sex. And we also said that if a value is not provided for color of spots, we're going to provide a default value of UNK, short for unknown. But in the current state, none of these constraints are actually being applied, right? So if we were to say something like insert into horses, name, color, spot, sex, weight, values, Sam, a black horse with spots that is male and 2,200 pounds, well, that actually works, right? And if we said select asterisk from horses, we now see that we have two horses that have the name Sam. Well, that's not good because we said we want to be able to uniquely identify horses based on their name, and that's not the state that we are currently in, right? Also, if we wanted to insert a horse that had the color pink, right? That shouldn't be allowed because pink is not in the domain of acceptable colors. However, this insert statement will work just fine, and you see we now have a pink horse named Pinky, right? We could also insert a horse that has an absurdly high weight, 91,050 pounds, right? So the point is we have some shortcomings in our data definition language code that are not properly enforcing all of the integrity constraints that we described in the business case. So let's take a look at resolving that. So the most straightforward way to do this, and especially since we have at this point just a very small data set, we're just going to delete everything and start over. And we're going to do that using this drop table command. So if we say drop table horses, that's going to drop our horses table, any constraints that are in place, as well as all of the data that has been inserted into this table. So the drop command is data destructive, and Oracle and most other DBMSs don't actually give you any kind of warning message or guardrails to protect you from doing something very dangerous. So you will notice when you run the drop command, you'll get this error message or this warning message from dbeaver, but this is coming from dbeaver, not from Oracle itself. So other SQL clients might not give you this warning message, or if you are connected directly to the database in some other way, you likely won't get any kind of error message like this. And as we'll see a little bit later in the semester, drops and other deletions can also sometimes cascade to other tables depending on the constraints you have in place. So improper use of the delete and drop commands can be what we refer to as a resume generating event. But in this case, actually deleting the table and the data is what we want to do. So I'm just going to swap back over to Oracle here. I'm going to say drop table horses. And now if I refresh here, you see that table is now gone. If I were to say select asterisk from horses, it says the table or view does not exist. All right, so now we are going to recreate our horses table with all of the constraints that were described in the business case. So recall that in the format of the create table statement, we have a comma delimited list of table elements, which can be the name of an attribute or a column that we're creating, or the definition of a constraint. Okay, so we can place these constraint definitions either on a line by themselves, or if they apply to just a single attribute in the table, we can often define the constraint just right alongside the attribute itself. So in this case, we have a number of constraints we are looking to apply. So we're going to say create table horses, open parentheses. Here's the name of our attribute, in this case name, the data type, which is a varchar 50, and then the keyword constraint to tell Oracle that we're about to define a constraint. We provide a name for the constraint, in this case PK underscore horse, because it's the primary key for our horse table. Now, this doesn't have any technical meaning to it. This is just a name that we are defining so that whenever Oracle maybe gives us an error message about this constraint, this is how Oracle is going to tell us where the problem is. Okay, so this is just how we refer back to the constraint that we have created. And the type of constraint this is the primary key constraint. Okay, so all this stuff that's in all caps and bolded here are like your special Oracle keywords. Okay, so this is defining that this attribute name is our primary key. Then we have the comma in our next attribute, color, which is a varchar 50. It has a default value of UNK, or for unknown. And then we're applying a constraint that we are calling check color. And again, this isn't any technical thing. This is just how we are referring to this constraint. The type of constraint is that it is a check constraint, meaning that it is going to check that the values of this attribute color are in this domain of values: black, white, brown, gray, red, yellow, or unknown. So that's our domain constraint being applied. Then a comma, the attribute spots, which is a varchar 3. It has a default of unknown. Then we have our attribute sex, which is a varchar 1. We have the constraint that it is not null, and we're calling that nn underscore sex. And then we have our attribute weight, which is an integer. And then here at the bottom, we have two additional constraints. One that we're checking that the value of weight is greater than or equal to 800 and less than or equal to 2200, right? So that our weight is between 800 and 2200 pounds. And then also a constraint that we're calling check sex, which is a check constraint, which is applying our domain constraint, that the value of the attribute sex is in this set of values M and F. So we certainly could have applied these constraints here on the same row that we're defining the attribute, right? We could put our weight constraint here and our sex constraint here, but we're just kind of illustrating here that we can apply these on lines by themselves. So I'm going to go ahead and switch over to Oracle, and we'll run this code to recreate our horses table with these data integrity constraints in place. Okay, so here we have just the exact same code that was present in the PowerPoint slides. So I'm going to highlight that, execute. And of course, we currently do not have any data in our horses table. So we're going to insert the horse data that we just saw a moment ago. So here are 8 horses. And now if we attempt to insert a new horse that has the same name as one of our existing horses, in this case Sam, we get an error message that says this violates our unique constraint PK horse. Okay? Now the reason this says PK horse is because that's what we called our primary key constraint right here, right? So when Oracle gives us this error message, it's telling us like the name of the constraint that's being violated as we defined it in our data definition language code. So like similarly, if we attempt to insert a horse that has a color or a value for color of pink, we get an error message saying that we're violating the constraint check color. And the reason it says check color is because that's what we called this constraint when we created the table in our DDL. Similarly, if we try to insert a horse that has a very high value for weight, we're violating the check weight constraint, and so forth and so on. So if we look back at the data in our horses table now, you can see none of these rows with invalid values for name or color or weight or what have you have actually been inserted, right? But of course we could insert a horse that has a slightly different name, right? We can insert a horse called Sammy, okay? And yeah, Sam and Sammy, I mean, these are unique values. That all works. If we wanted to insert a horse, named Pinky that is actually red instead of pink, that works. If we want to insert our horse Hulk that has a value not of 91,050 pounds, but 2,050 pounds, that'll work just fine. Could also insert a horse, Pat, a white horse with no spots, female, 1,400 pounds. And you see now we have all of these horses. Now we could also insert a horse that doesn't have a value for color, spots, or weight. We could just provide values for name and sex. And since in our DDL code, we provided a default value for color and spots of unknown, that will automatically be applied. And then if we didn't specify any default value for weight, so weight is just going to have a value of null. So if we were to do something like this, we could say insert into horses, name, comma, sex, values, and let's say Betty, the female horse, and select asterisk from horses. We see that as expected, we had these default values of UNK inserted for color and spots, and then we just don't have a value for weight. All right, so now if we wanted to go back and actually provide good values for color, spots, and weight for this Betty horse that was just inserted, we can use our update command. So we're going to say update horses set color equals white, spots equals yes, weight equals 1,250, where name equals Betty. Okay, so this is going to evaluate this Boolean expression for every row in this table and look for rows where the value of the attribute name is equal to Betty. And then for all of those rows, which is only going to be one row because name is a unique identifier, it's going to set the value of these particular attributes to the values that we have specified here. Right? So we could say update, I have to spell it correctly, update horses set color equals white, spots equals yes, and weight equals 1,250, where name equals Betty. And it says we updated one row, which is what we expected. And now we see Betty has good values populated here. Now, if we were to do this update statement without the where clause, it will update all rows in your table, which we'll see some examples of that a little bit later in the semester. That is certainly something that is possible to do and occasionally might be what you want to do, but is not commonly what you want to do. So the vast majority of the time when you do an update statement, you're also going to want to have this where clause at the end. All right, so once a table is created, we can also alter the schema of that table using the alter table command. So we can do things like add new columns, we can alter existing columns, changing their default definition or dropping their default definition. We can get rid of columns with the drop column command. We can add new constraints, remove constraints, really anything that we can do with the create command. So let's imagine for a moment that we want to now track not only our horses, but also the name of the owner of the horse. Okay, so instead of dropping the table and recreating it like we did previously, we could use the alter command to just add an attribute called owner. So we would say something like alter table horses, add owner, this is the name of the attribute, and then the data type for that attribute. In this case, we'll make it a varchar 50. Okay, so here's the SQL code that we just saw in the slides. It says we've successfully altered the table, and now if we say select asterisk from horses, we see all of our horses just like before, but now this new attribute called owner, and we have a value of null for each horse. So null is the absence of any value at all. This is saying we don't know what the value for owner is for each one of these horses. We haven't provided a value. Now we'll talk more about null a little bit later in the semester, but one thing to note is null is not the same as 0. And null is not the same as just a blank space. So a 0 or a blank space or something like that is a value, right? That's saying the value is nothing, right? What null is saying is we don't know the value. We don't know if the value is nothing. We don't know if the value is supposed to be something. Like this is the absence of any data whatsoever. And it's kind of a weird way of thinking about things. And in fact, in database design, we typically want to avoid having the presence of a lot of null values. It makes your data interactions a little bit weird, and we'll see many examples a little bit later on of why this is the case. But generally speaking, we want to avoid having a whole bunch of null values. So let's go ahead and update our horses so we have a value for this owner attribute that describes the name of the owner of the particular horse, right? So we could do something like update horses, set owner equal, and then let's say this is like a username of the person who owns the horse. We're going to say C. Anderson at this point, where the name of the horse is equal to Erica, right? So this Boolean expression is going to be evaluated for every row here. For this horse Erica, we're going to update this row so that the attribute owner has a value of C. Anderson. Okay, so when we do this, it says we've updated one row. And you see now the horse Erica has a value for the attribute owner of C. Anderson. We could also update multiple rows at once. So we could do something like this, update horses, set owner equal T Swift, where name in this set of values, Betty, Pinky, and Rio. Okay, so this expression is going to be evaluated, and if the value for name is in this set of values, Betty, Rio, and Pinky, we're going to update the value of the owner attribute to be this value, T Swift. Okay, so we execute that. It says it's updated 3 rows. And sure enough, we see that this individual T Swift is now the owner of these 3 horses. We'll do one more update here. So now you see we have some horses that do not have an owner, and then we have some horses that are owned by some individual. Now, as I mentioned before, we can do an update statement without having a where clause at the end of it. And if we were to do something like this, say update horses, set owner equal M Grimes, that's going to update every single row in the table. And again, this is possible, but it is uncommon. And in fact, it is so uncommon that dbeaver even pops up a little warning message saying this is a dangerous query that you are executing. But again, this message is coming from dbeaver, not from Oracle. So don't become too dependent on your DBMS giving you some kind of warning message, because many DBMSs will not do this. And if you are just sending commands directly to the database, for example, through an application that you've written, you're never going to get any kind of message like this, right? But let's just take a look at what happens if we do execute this code. Let's say update horses, set owner equals M Grimes. Says it updated 13 rows. And yeah, now in fact it has this user M Grimes as the owner for every horse. Now we could execute these same update statements that we just did a moment ago and fix this for these 6 horses. And okay, now we have kind of a more reasonable looking situation, right? Where we have some horses owned by these people, and then M Grimes is the owner of all of the other horses. So as mentioned, the alter command would also allow you to drop and recreate constraints. So if we wanted to modify our color constraints such that we would allow a color like pink, we actually cannot change the constraint in place. We have to drop the constraint and then recreate it. Okay, so we could say alter table horses, drop constraint, check color, right? And at that point, after we execute this command, there actually is no domain constraint on this attribute color. So the very next thing we would want to do is to recreate that domain constraint, and we could add in pink as a color that we allow, right? So let's flip back over to Oracle and take a look at that. If we said alter table horses, drop constraint, check color. Now at this point, we could create a horse of absolutely any color, which is not what we want to do based on the business constraints we've talked about. So we want to go ahead and recreate this constraint, checking that the color is in this set of values: black, white, brown, gray, red, yellow, now pink, and unknown. So if we do this, now we could update horses, set color equal pink, where the horse's name is equal to Pinky, and this works, right? So select asterisk from horses, and you see we have Pinky, the pink horse now, right? Now we still couldn't set the color equal to purple or something like that, right? Because that's still a violation of that domain constraint. But we can now have pink horses. But now let's imagine that, okay, so we decided we wanted to allow for pink horses, but then we kind of thought better of it and said, you know what, maybe it's a little silly for horses to be colored pink. So we want to actually get rid of that. We want to revert our constraint back to just the colors black, white, brown, gray, red, and yellow, right? So if we wanted to do that, we would just need to drop the color constraint and recreate it just like we did to allow the color pink. So let's drop our check color constraint And then let's attempt to recreate it. So we're checking the color is in black, white, brown, gray, red, yellow, no pink this time around. Oh, but now when we try to create the constraint, we get an error message saying that we're violating the constraint that we are creating, right? Because there is already a horse that has a color that is not in this domain of values. Okay, so if we wind up in this situation, there's kind of two different approaches we could take. One, we could modify the existing data values to make sure they are not going to violate this domain constraint, or we could add a command here at the end that says no validate. Okay, so this is going to say for any existing data, we don't enforce this constraint, but no new data going forward would be allowed to violate this constraint, right? So if we add this no validate command at the end, we are able to put this constraint in place. And you see we do have Pinky, the pink horse. However, if we tried to update an existing horse or insert a new horse with the color pink, we're going to get an error message saying we're violating that domain constraint. We can also use the alter command to drop columns or attributes. So if we decided we didn't want to keep track of spots anymore, we could just say alter table horses, drop column spots. Okay, so currently you see we have this spots attribute here. We said alter table horses, drop column spots. Says our alter command was successful. And now when we select asterisk from horses, you see we no longer have an attribute called spots. And of course, all of the values for that attribute are also deleted and gone forever. So that was a data destructive command, something you want to be very thoughtful about before you execute something like that. So while drop is used if we want to get rid of an entire structure within our database, if we want to get rid of an entire table or get rid of a constraint or get rid of an attribute, if we want to get rid of just particular data values, right, not the database structure itself, but just the values, we can use the command delete. Okay, so if we wanted to delete all of our horses that are owned by a particular customer, in this case, T Swift, we could say delete from horses where this Boolean condition evaluates to true, where the value of owner is equal to T Swift. Okay, so that should delete these 1, 2, 3 horses here. Okay, so if we say delete from horses where owner equals T Swift, says we've updated or deleted 3 rows. So we went from having 13 horses down to just 10. Now, of course, if we did not specify anything in that where clause, if we just said delete from horses, that is going to delete every value from our table. So now if we say select from horses, you see we have no data left whatsoever. However, we do still have the structure of the table, right? These attributes, name, color, sex, weight, and owner. Okay, so at this point we could insert horses back into the table. The table still exists. There's just no data in the table. So if we want to get rid of the table altogether, we would say drop table horses, and then the table itself is gone. If we try to say select asterisk from horses, we don't get just the kind of empty table with the attribute names at the top. We get an error message saying this table or view does not exist. So the entire structure of the table has been removed from the database. And since we made a few alterations to the structure, like getting rid of our spots column and things like that, that's kind of where we want to leave this off for module 10.1. In module 10.2, we'll go ahead and recreate this table along with all of the attributes we need, all of the data integrity constraints, and then some additional tables that's going to be interacting with our horses. So that's coming up in module 10.2. I hope you enjoyed this introduction into data definition language, and we'll see you in the next module.